So we have discussed about the semi-structured data ingestion into the Snowflake as part of the last session, right? So whenever we are talking about semi-structured data, it could be JSON or Parquet or XML or ORC. It could be anything. But mostly I have seen CSV is the majority portion of the data projects are there, and a few of the projects I have seen like using JSON, Parquet, and very rare have seen about the XML. But other than that, nothing else. Like most of the projects are not using any other files, ORC and all, Avro and all. Okay, so now, so for CSV already we have seen. For semi-structured, I have taken example of JSON data. So the process, everything will be same for the all kind of semi-structured data. Either you can take a Parquet or you can take XML. It will be kind of same process only. So since majority of the portion, 80 to 90% of the projects are using either CSV or kind of a JSON or Parquet. So JSON or Parquet, both are it pretty much same. There is no slight syntax difference will be there in the form of that JSON file, key and pair, but remaining all same. So now in order to read that particular semi-structured data, so we have seen like if it is a kind of a one-on-one mapping, you can go with the dot notation colon. So that we have seen already as part of the yesterday's session. So this we called as a dot notation. So there is another way you can use one built-in function, lateral flatten. Lateral flatten. So this lateral flatten is basically built-in function provided by the Snowflake, and this function will be passing table and a column as an input to that particular function, and that particular function it will extract the metadata and value as well. Metadata in the sense key and the corresponding values from that particular table. So now when check this particular table, so these are the keys. So one thing is pretty much clear here. Whenever you are dealing with the semi-structured data, you need to use variant data type as a single column, and you are going to insert the data into that particular single column, that entire data in the form of either JSON or Parquet, whatever it is. And when we are inserting the data into that particular table, or you are loading the data into that particular variant, so you are going to receive the data in this format. So when you are receiving this particular data in this format, so CSV means we have a header. This is the column name and these are the values and all. But coming to JSON, so there is no concept of header and all. Here we have a keys. Keys is nothing but a header in the CSV file. So now keys here is a each dog is a key and name is a key and species is a key. Now these are the values. True, Fido, dog is a values. So now if you want to see what are the columns and the corresponding values from this particular JSON data, at that time you can use this particular literal function, because when you are using the dot notation, you will get the corresponding values into the table. But here when we are dealing with the JSON, and if you want to see the metadata columns and all, it's a different case. You can use the lateral flatten function, and this is the built-in syntax. It is a standard syntax. So what we are doing for this particular function, we are just passing as a input to the table name and column name. So now if you see, pets is a table name and V is the column name. Similarly, for that customer table, A is the table name I have given here, and column 1 is the this particular. So column, whatever we are using is a variant column. So now if you see, this is the complete JSON value. And if you see, I have segregated key and value separately. Each dog is key and value true. So since I have three key pair attributes here inside this particular JSON template, so I'll get 3 records for each one. If it is a more, then you'll get more. So now in customer table also, we have a 8 or 9 columns are there. So for each entry, you'll get 9, 9, values. If here I'm just filtering out only that call customer name, so I got only one. But if I'm not filtering anything, I'll get everything. Whatever the records are there. We take here address, this is the address, then you can see account balance, address, comment, customer key, management, all these values will come. If this particular attribute having three keys and values, you will get three separate records. It depends on how many number of attributes are there inside the JSON template. Those many records you will get into the particular table when you are using a literal flatten function. That is the uses of literal flatten function. So this can be used for all the semi-structured data types. Okay, is it clear?
Yes, sir.
So now today we will see about the Snowpipe, continuous data ingestion. We have seen about the bulk data ingestion, right? So bulk means batch processing. You are getting data in the form of a single file. So you are going to schedule the job daily once or twice or weekly once, daily once or weekly once. It depends on our business use case. So most probably we'll schedule as a daily once. But what if I want to get a near real-time data? I mean to say, I don't want to wait that much lag. I don't want to wait one day lag. See now, if I'm scheduling my job every day at 6 o'clock, so there is almost one day lag is there, right? So if today my job is running at 6 o'clock, I'll be getting from morning to till evening 6 o'clock, whatever the data is there, I'm getting the data in the end of the day. Now, if you want to see tomorrow only, you can able to see that entire data and all, right? But I don't want to be kind of that much lag. I want to be bringing the data every 15 minutes or every 30 minutes so that I'll get almost near real-time data. So in such kind of scenarios, and you are going to use this particular concept, Snowpipe. So today, as part of today's discussion, we'll see what is Snowpipe, how when we used to Snowpipe, and how to trigger the Snowpipe, how to manage this particular Snowpipe workloads, and what is the key differences between bulk load and continuous load. We will discuss it. So Snowpipe is a continuous data ingestion, right? Bulk load is a not a continuous data ingestion. Snowpipe, whenever you are talking about Snowpipe, it is a continuous data ingestion. Basically, you are building on pipe, and through that pipe, you are continuously ingesting the data into the Snowflake in the form of micro batches. So the Snowpipe is a Snowflake continuous data ingestion services, and this option is recommended for small volume of data. It's not like if you are having some kind of a 5 GB, 6 GB file and you want to ingest through Snowpipe, that is not going to be work out as expected. Means still you can use it, but it will take so much time and it will take a lot of compute power. So if it is a kind of a huge volume of the data, you will go with the bulk load. But if it is a kind of a small volumes of data, so small values in the sense when we will get these small volumes, when we are discussing about the data warehouse concepts, we have discussed, right? Full load, incremental load. Full load in the sense every day they're going to send the full data, and incremental means every day they're going to send only latest or updated records, right? So now for example, I have 1,000 records. So today I have received the 1,000 record as a one-time load. First day I have loaded those 1,000 records into my table. Next day, if in case it is a full load, I'm going to receive 1,000 records and plus 10 additional records, total 1,010 or 1,100 records I am going to receive. So next day I need to load 100, 1,100. Next day, third time, I would have been received 1,500. Those out of this 1,500, maybe 1,300 is a old one, the remaining two are a new one. It could be latest records, or out of this 13, it might be updated records are there. So which means kind of a full load means always you will get old records as well as a new records. So entire data set they will export from their table and they will send in the form of feed file to you. And you are going to truncate that table and you are going to load this entire data into that particular stage table. That is the process for the full load. So now when we are moving the data from the stage to int, we are going to run the merge statement. So the merge statement, it will basically, if there are any existing records are modified, it will update it, and the remaining records will be inserted. So if you want to apply if you want to maintain the type 2, type 1, it depends on the business use case. I'm just taking an example of as a type 1. So now coming to incremental load. So incremental load in the sense, first day you have received 1000 records, and next day you have received only 100 records. So out of these 100, it could be 80 records are completely new records and 20 records are modified records. So you are not going to receive the old data. You are just going to receive the latest data, updated data. So this is we called as a incremental. So now incremental, always you will get a less number of records, not like a full load, right? So whenever you want to implement these type 2 implementations, so like if you want to ingest this particular data into that Snowflake table, you can use this Snowpipe concept. So the Snowpipe is recommended for micro batches ingestion, and it will continuously load the data into the Snowflake, right? And the Snowpipe, another beauty of the Snowpipe is, as soon as that file is arrived into that particular S3 bucket or particular stage, internal named stage, automatically Snowpipe will process the data. You don't need to take anything. So it's like every 5 minutes or every 10 minutes, you are going to upload the file into the particular stage. Now Snowpipe, it will automatically process the data into the Snowflake table. And that is what about the third point. So Snowpipe provides a pipeline for loading fresh data into micro batches as soon as it is available. As soon as it is available in the sense, as soon as the file arrived into that particular stage, automatically the Snowpipe will process the data. And the Snowpipe, another benefit with the Snowpipe is it is going to use the serverless feature, serverless architecture. What is mean by serverless architecture? So we know, if you want to execute a particular query from the Snowflake web UI, you need a dedicated warehouse in order to use the compute power, right? Without having a warehouse, you cannot you cannot execute any query in the sense except the metadata operations. For suppose employee table is there. If I want to run the select star from employee where department number equal 10. So if I want to execute this particular query, definitely warehouse is needed. So if though we are not using any warehouse, that query execution cannot be happen, right? So that is basically we are providing the compute power manually, explicitly. Okay. But coming to the Snowpipe, so this is a kind of a serverless architecture, which means you are not going to provide any compute power, and it is completely taken care by the Snowflake. So how much credits is using, how to execute the Snowpipe, everything it will be taken care by the Snowflake. You don't need to worry about explicitly create a warehouses and monitoring that warehouses, how many credits are consuming. You don't need to do any privileges stuff. You don't need to do anything. So it is completely handled by Snowflake. So as soon as the workload is completed, automatically the Snowflake will brought down the compute resources. That is the beauty of this Snowpipe. Is it clear so far? Anybody has any queries?
No, sir.
Is it clear, right? What is mean by Snowpipe? What is the recommended approach for the Snowpipe? Snowpipe is a database object in the Snowflake, and it is useful for the processing the or continuous data ingestion. So it is recommended for the processing small amount of data in the form of micro batches. So the Snowpipe will use the serverless architecture and serverless billing model, which means this compute resources, everything will be taken care by the Snowflake, and you can use the Snowpipe for internal stage as well as external stages. I hope all are clear. If not, please let me know. Okay, so how we can trigger the Snowpipe? So we are talking about the Snowpipe. So now we are saying like as soon as the feed file is arrived into the particular stage, it could be internal or it could be external. The Snowpipe will automatically process the data, right? So how the Snowpipe is going to automatically process the data? So now if you take a 3 cloud platforms, S3, bucket, blob. So in S3, we have a services called SNS or SQS. So this we called as a simple queuing system. SQS means this is another service. We have seen S3 right in AWS. Similarly, SQS also another service. A simple notification service SNS. These are the three services commonly we'll use in a Snowflake space. We have already discussed about the S3. We'll see about the SNS or SQS also next session. So now what these particular services will do, so these are kind of a notification services. So we used to get a promotional messages, right? Kind of from Flipkart or Amazon. If there is some sale is going on, we used to get promotional messages to our mobile, right? So how they're sending these promotional messages? So they cannot sit and they cannot send individual person, right? So they'll have a thousands of customers in their database system. So they want to send in a single go this particular message for everybody. So for those kind of activities, they're going to use this particular SQS or SNS notification. So notification in the sense, so as soon as my feed file is arrived into this particular S3 bucket, so this particular SNS or SQS, it will say to the Snowpipe, hey, there is a new data is arrived into the S3, please process it. They'll just send a notification. So as soon as this notification is sent to the Snowpipe automatically refresh it and it will load the data into that particular Snowflake table. So this particular thing will be applicable for all the cloud, all three cloud platforms. If you are using a blob bucket in Azure, you are going to use a sub means publisher sub subscription. So you can read the data. Now you are going to GCP, Google Cloud Platform, you can go with the event grid. So these three, like any cloud platform, you are going to use that corresponding notification services with respect to that cloud platform, and you are going to inform to the Snowpipe. So we have already mentioned, right? As soon as feed file is arrived into that particular stage, automatically Snowpipe will process the data. But in order to get to know the Snowpipe, if there is a data, new data is arrived, we need to set up something, right? So these are the alert mechanisms. You are going to set alert, and as soon as the feed file is arrived into that particular stage, automatically this alert will trigger and it will alert the Snowpipe. So as soon as alert is received, the Snowpipe is refresh it automatically and it will pick up the new data and it will process into the Snowflake table. This is how the Snowpipe is going to trigger. So other than these cloud platforms, you can use a Python and you can use other programming languages. You can use a REST API. Still, you can call that by using the REST API, this particular Snowpipe, but those are not actively using in a real time. The real-time projects mostly will use Snowpipe with this any one of the particular service, cloud service. Is it clear or anybody has any queries? What about others? Okay. Until if you are raising your queries, I cannot help, guys. So I'm keep on saying same thing. If you are not clear, you want to raise your voice. Otherwise, nobody is going to help you. If later point in time you are coming back and you are saying, I'm not able to get it, I'm not able to understand, nobody is going to help you. So now we'll see what is the difference between bulk load and Snowpipe. So bulk load we have seen copy command, right? So now Snowpipe. So what is the kind of a key factors when we are dealing with this bulk load and Snowpipe? So by the time we have a already couple of points we know. One is bulk load deals with the huge files. Snowpipe will deals with the micro batches. And bulk load, it is frequencies kind of a less frequency. I mean to say daily once or weekly once. It depends on the business use case. And also bulk load, we need to manually execute the copy command, or you need to call the store procedure. Basically, you need to take care something from your end. Now coming to the Snowpipe, so it will the frequency is very less. I mean, it is almost bring the near real-time data into the Snowflake, and as soon as any new file is arrived into that particular stage, Snowpipe automatically process the data. So these are the key points we have already discussed. And another key important point is bulk load will going to use the manual compute power, in the sense explicitly whatever the warehouse you are defining, it is going to use that particular warehouse and it will execute that corresponding commands. But coming to the Snowpipe, it will use the serverless architecture, which means it will be taken care by the Snowflake. These are the key differences we have seen so far. Okay. So now coming to the few more key parameters when we are dealing with the bulk load and Snowpipe, how these parameters will differentiate it, we'll see. One is a load history. So load history is a kind of a dictionary. So from where you can see the how much data is loaded, how many files are loaded, everything you can able to see from the load history and copy history. So we have two major data dictionary tables from the Snowflake side, especially for the data ingestion part. One is a copy history, another one is a load history. Copy history is basically we have discussed about the copy command, right? So what are the files are successfully loaded into the particular table, we can see from the copy history. Similarly, load history also you can able to see that information. So when you execute a copy command, so those particular metadata details will be available in this particular role history data dictionary up to 64 days. So you can see from last 2 months what are the feed files you are loaded into the Snowflake by using the load history. There are certain cases if you want to backtrace how many files we have loaded, what is the data volume from last 60 days or 64 days, you can able to see it. But coming to the Snowpipe, it is not having that many days of metadata backup. Will have only 14 days. It have only 14 days. So after 14 days, if you are not using this particular Snowpipe, it will become stale and automatically you lose your metadata also. Metadata in the sense, it is just kind of a history reference. What are the files are got processed successfully? You are going to store this data into that particular table. Now coming to the transactions. So loads are always performed in the single transaction. Data is inserted into the table alongside any other SQL statement submitted manually by the users. So now what it's saying, so in bulk load, it is a kind of a single go, right? As I mentioned, it is a always one time load. Whereas coming to the Snowpipe, it is not always as a one time load. For example, if you schedule that pipeline every 10 minutes or every 15 minutes, so throughout the day, every 15 minutes, you are receiving a feed files and you are processing the data into Snowpipe, right? And compute resources. So required user specified warehouse to execute the copy statement in case of bulk load. Whereas a Snowpipe, it will take care about the Snowflake supplied computer resources. Cost is billed for the amount of time each virtual warehouse is active and running, right? So bulk load, as I mentioned, we are explicitly specifying that particular warehouse. So it will check what is the size of warehouse and how much time it is actively running. Based on that, they will charge. Now coming to the Snowpipe, it is a completely serverless architecture, right? Which means Snowflake is going to be process it. So how much actual work is done at that time, what is the compute power it utilizes, only you are going to pay for that. So now how we can make a difference between the serverless architecture and this particular compute virtual warehouse. So now while creating the warehouse, we'll give a parameters auto suspend and auto resume, right? So auto suspend, I have given 5 minutes. So if I'm not using this particular warehouse from last 5 minutes, automatically that warehouse should shut down. It will, should become a suspend. Okay. So now I have given a particular query. Okay. So now the warehouse is being up and that query is execution completed 1 minute. Okay. So actually I have set up auto suspend as a 4 minutes for that particular warehouse, but my query execution completed in 1 minute. So the remaining 4 minutes that warehouse is a active, right? So they will charge something for the remaining 4 minutes. So that is a kind of a case of copy command or user defined warehouses, virtual warehouses, UCS. So there is a kind of a key portions when you are dealing with the queries execution and all. So now unnecessarily you need to pay some amount for the, even though you are not executing anything, since you set up that particular warehouse, suspend time is a more, but your query execution is completed within the time frame like less than 1 minute and all. So the remaining 4 minutes or 3 minutes, it's became a waste of resources. Okay. So that is the case of user defined compute warehouses. Now coming to the Snowpipe, that is not the case because the Snowflake is actively looking and it will give whatever the compute power is required. Once that compute power is done, automatically it will shut down that compute resources by Snowflake. There is the advantage with the serverless architecture. Is it clear about the differences between bulk load and Snowpipe? Anybody has any queries? So it's very simple, okay? Simple key points. Bulk load will deal with the huge data. Snowpipe will deal with the micro batches data. And bulk load kind of use the different compute powers. Snowpipe, it will use the serverless architecture. And Snowflake will be supplied the compute power. Now coming to the bulk load, the frequency it could be kind of a daily once or weekly once as per the business use case. But coming to the Snowpipe, it is a kind of a every half an hour or every 1 hour. So basically compared to the bulk load, this frequency is more because we are trying to achieve the near real-time data and it is a continuous deployment, right? Bulk load is not a continuous ingestion. Snowpipe is a continuous data ingestion. Is it clear or anybody has any queries with respect to these things?
Yes, sir, clear.
Okay. So now there are these are the certain areas like people will ask scenario oriented questions and all. Okay. So whenever I'm giving some examples, please note those. Please go through the recordings and please note those. Those are the could be your scenario oriented questions. Okay, so now files modified and staged again within 14 days, what will happen? Snowpipe ignores the modified files that are staged again. To reload modified data files is currently necessary to recreate the pipe object using a create or replace pipeline syntax. So what it is mean? So now we know when we are running the copy command, if once the file is processed successfully and loaded the data into the table, even though if you are executing the copy command, it won't process it, right? Because it will check the stage and copy history metadata, and if the data is already present it won't look at, right? That's what we have seen, right? So now once this file is processed, you cannot process it again. That's where we have discussed we need to use the force parameter, right? When we are discussing with the copy command, we have discussed that. So now that is the case here also. If once the file is processed through Snowpipe, it won't process it again. Even though you modified something in that file and you didn't change that file name and you just uploaded that file again, it won't process it because it will look at that particular file name from the load history or copy history. If the file is got successfully processed it won't touch again. And if you want to process that file again, you need to recreate the Snowpipe. Okay. This is a time frame 14 days. But if like after 14 days if you reload that file again, same file, it will process it, but it will make a duplicate entries into the target table. So this will be taken care as part of the real-time projects. These rare scenarios will get these things, but the logic you need to understand. So we have already mentioned the load history will maintain the history up to 14 days in Snowpipe. So once the file is processed till next 14 days, it will look at these. Whenever it receive a request, it will check if that file is already processed or not. So since the file is already processed, it won't process it. If it is not processed, then it will process it.